Welcome to our first section in Chapter 1, 1.1 over functions and function notation. So we're just going to kind of hit some basics of these to get the idea of what a function is, and we're going to kind of do it in multiple ways with tables and graphs and also with actual mathematical rules or functions. So, what is a function? The natural world is full of relationships between quantities that change. When we see these relationships, it is natural for us to ask, if I know one quantity, can I then determine the other? This establishes the idea of an input quantity, or what we refer to as an independent variable. And it has a corresponding output quantity, which we end up referring to as our dependent variable. And so as I input one, the output then becomes the dependent. It's dependent upon what goes in first. So a rule for a relationship between an input or independent variable, quantity, and an output or a dependent quantity in which each input value uniquely determines one output value. Oops. Now we say that the output is a function of the input value. So it's kind of backwards in that sense. The answer is a function of the input or the result. So what do we have here given some specific situations? Can we determine what depends on the other? And sometimes it's nice to know what is the one that depends on the other because that's the output. Given a specific person in any age, it is easy to determine their height. Is height a function of age or is age a function of height? So if we think about our input and our outputs, what do I have? Well, I have height and age. If I, for the height of myself, how tall I am, is that dependent upon my age? What has to happen first? Well, if I say I'm 5 years old versus 56 years old, what's going to happen to the height? Well, the input does have to be your age. That has to be known first. And then your height, your height would then be the output. Okay? So if I'm wondering about is height a function of age or age a function of height, remember we want the output to be a function of the input. And so therefore we would choose that height, since that's the output, is a function of age. So that would be the answer to our question that we have going on there. Oops. Okay. Now, at the next example, at a coffee shop, the menu consists of items and their prices. So again, do the items determine the price, or does the price determine the items? Which way is it normally? Well, when you go into a coffee shop, it's not like I have $5, what can you give me? It's I want a pastry and a small coffee. So the input has to be the items, and the output has to be the cost that we have incurred by those items. So again, output is a function of input. The money is a function of the item. So the price is a function of the items. That's the order that we would take it. Okay. Now, our next one says, in many classes, the overall percentage you earn in a course corresponds to a decimal grade point. Is the decimal grade point a function of the percent, or is a percent a function of the decimal grade point? So think of the grade point as kind of your GPA and your percent. So what is my input? What is my output to answer this question? Well, the grade point is always determined upon what you get on a test or the percent that you get. So our input in this case is going to be our percent, and then the output is going to be our grade point average, okay, our GPA. And so which order is it? The order is that we want to have our output is a function of our input. Therefore, the decimal grade point of a function, that the decimal grade is a function of the percentage, because grade is our output, percent is our input. Okay? So, being able to determine what is going in, what is coming out of a function in that sense of things that change together. Now we turn our attention to one-to-one function. A relationship that we've talked about is considered to be one-to-one if each input corresponds to exactly one output, and that actually makes it a function. And every output corresponds to exactly one input. So, the first statement there corresponds that we have to have a function to begin with. Next, when I go backwards, that means that every output has exactly one input. Okay? Now, function notation. Let's do a little bit of this function notation first, and then we'll talk about being able to identify a function and whether or not that function is one-to-one. So function notation is basically just simplify your writing when you're talking about different situations. So to simplify writing out expressions and equations involving functions, a simplified notation is often used. Many times, descriptive variables are used to help us remember the meaning of the quantities in our problem. So I will tell you that a lot of times a function is y is equal to f of x. When we're just generically looking at relations of each other, then our notation is usually that. But when you have things that have meaning to them, situations that have meaning, then you can use letters that represent what you're looking at. So for instance, if I want to write height as a function of h, I'm going to let h equal my height and a equal the h. So now I can use h and a in this situation. So if our height, call that h, in math, this two little word means something very, very important. If x is 5, that means x equals 5. If height is a function of age, then our height equals a function of our age. So in this case, I'm going to write that as f of a. So h equaling f of a is one way to simplify our notation, but also I could write h of a as another way in order to write h as a function of a. A being your input, it is always on the inside, and our output is on the outside. Now, this letter f could be interchangeable, so I could write h equals g of a, and it means the same thing. It's just a name for a function. You don't have to have meaning on that specifically. So, the notation h of a shows that h depends upon a, and that the value a must be put into our function a, that's the input, into my function h, to get the result. Now, be very careful. When you see parentheses like this, if I were to say something like 2 times 3, then in that sense, that means to multiply when we're working with numbers. Be very cautious. These parentheses here do not mean to multiply. They are just a notation to correspond with our function variables that are going on. Okay? So, here's kind of a generic form. If we say our output equals the function of our input, so f of our input. And that is kind of a generic form that we have there. Okay? All right. Let's move forth on this example. Introduce function notation to represent a function that takes as input the name of a month and gives as output the number of days in that month. So input is the name of the month, and our output is the number of days in that month, okay? So let's choose 2 letters to represent each one of these. You could choose N for name or M for month if you choose. And an output for the number of days, I would choose like D or something to represent days. Now, if I want to do that as a function, remember, this is my input, so that must go on the inside of my function. And this is my output, which must go on the outside of that function notation. So if I were to write that my days are a function of the month, then I would end up having D is equal to F of M, and that would symbolize our function notation for this case. Okay? All right, last example, a function N equaling F of Y gives the number of police officers, call it N, in a town in year Y. So we have 2 letters there, N and Y. What does F of 2005 equaling 300 tell us? So we're going to put meaning to that. Now go back to what we have here. Inside is our input. It is our independent variable. It is Y, which represents the year. So what's inside there is designated as the year. The N on the outside of what it's equal to represents the police officers. So the N, or the number on the outside, talks about how many police officers you have. So if I have specific numbers of 2005 and 300, that means in 2005, there were 300 police officers. Okay? So, in 2005, there were 300 police officers. Is the meaning of the F of 2005 equals 300. Again, a simpler way to write things and be able to simplify what we have going on there. Okay? All right, let's turn to the next page. This gets us into kind of our math stuff. That was some meaning behind it. This will give us some math information with tables. Then we're going to do graphs. And then we're going to talk about actual functions that we have, okay? So in this table, express up there can be done in many ways: words, tables of values, and graphs or formulas. Then, when looking at tables, these are made up of input values and output values. So here's my input across the top. There's my output across the bottom. And sometimes the values have meaning, while other times the values are just a relationship in a table. So our question is here, are the following tables functions, and are they one-to-one? Now remember, for a function, that means that I had to have basically unique x values or unique inputs. Everything that's going into my function has to be different. So if I look along here in my number or my months, 1 through 12, notice they are all different. So is it a function? Yes, because they are all different. Now, is that one-to-one? Well, we already know that partway it is one-to-one because it is a function, but I have to ensure that the other way is the case as well. That means that for every output, I have exactly one input. So if I look here, notice here, I have multiple outputs that are the same thing. And because of that, that means we are not one-to-one. Okay? Function, basically you look at your x's. If they are all different, then for one-to-oneness, you look at your y's to see if they are all different again. So for this relationship, I have N as my input and Q as my output. And so if I look for a function, is this a function? That means that I have to have unique x values. It can't go to more than one y value. Therefore, since I have unique 1, 2, 3, 4, 5, this is a function. If I then turn on the other side now and look at my output values and determine, does every output value have exactly one input value? Well, again, your question should be asked, are these unique? Well, I'm circling the 6's, or actually boxing the 6's and circling the 8's. Notice that you have 2 of the same exact things. Therefore, that kicks out. 8 can't go to 5 and 1 at the same time. It can only go to a single number in the x. Therefore, this again is not one-to-one. The next function works about the